Hello guys, in the previous video we were studying data flow testing, right? What is exactly the data flow testing? So in the module 3 we know the first part is regarding the statement testing, branch testing, the loop testing, the block testing and all, right? That is first part. In the second part we studied the path testing. So what exactly the path testing? Under the path testing we know the definition of a path testing, and also we know the important type of path testing, right? The Maccabe's basis path testing. Why actually the basis path testing required and all, we already studied that one, right? So in the data flow testing also, in the previous video we studied that one. So how data actually flows from one point to another point, right? In data flow testing we know there are two important things. The first thing is regarding variable, where it actually defined. This is the first point, and where it actually used. That is second point, right? So when you are conducting a data flow testing for a for any program, right? We actually conducted one data flow testing in our lab program, right? The program ninth, right? Ninth is based on the data flow testing. There, in the commission problem, what we actually did is we executed the program, right? For the commission problem we plot a graph, a program graph, and right. So we plot a graph, right? In that graph, what actually we did, so in that graph, uh, a program we actually written the program with the line number. Each line number is considered as a node. So we plotted a graph, and for each variable different variables are there in commission problem, right? For example, logs is there, stock is there, barrel is there. Logs, stacks, barrels, total stocks, total barrels, total barrels, and these are all different types of variables. For each variable we define the point where actually the variable is defined, and where actually it is actually being where actually it's actually being used, right? Being used. So this is the main thing. Data flow testing, always remember, we need to define 2 points where a variable is defined. This is first point. In the second point, you need to define, you need to write where a variable is actually used. This 2 point is very important. So in lab you have only one program, right? Data flow testing, commission problem. So in the commission problem, different for each different variables, you what you actually did, you you listed different variables which comes under the commission problem. For each commission problem, sorry, for each variable, you uh, you define where actually it is defined, and where actually it is being used. Okay, these are 2 points you you mainly focus, right? This is the main thing which comes under what, commission problem, in the data flow testing approach, right? So you conducted the data flow testing, so you should need some strategy for conducting the data flow testing, right? The important points regarding the data flow testing. So these are some important points which comes under data flow testing. So in the data flow testing is indicated in, usually there are three main areas, three main scenarios. There only this data flow testing is indicated. Okay, the first thing is computation intensive application. A application which uh, which actually has many computations and all. Computation specific or computation intensive application. In this kind of application we are going to use the data flow testing. right? Because there are many different computations will come in, especially in the commission problem also, of course. There are different computations, like you need to compute the total logs, the total number of logs and all. Of course, coming to the programming point of view, of course you have only a few calculations, but when you dealing with the real world applications where the computation is the main thing, you need to conduct the data for testing, because there are many variables are there. For each variables you need to define, you need to you need to conduct the data for testing. You need to make sure that where actually it is defined and where actually it is being used. Okay, so then only you need to conduct the, or you need to execute the test cases for those variable. Okay, so for that purpose, uh, this data for testing is mainly used in the computation intensive application, as well as the long programs, right? Where the program actually has you know long statements. The number of lines are more. So in this case also, the long program also, we're going to use the data for testing. This is another case. This is another uh, scenario where actually we're going to use the data for testing. And the third one is the programs with many variables, of course. First one is the computation intensive application, second one is the long program, third one is where the program contains large number of variables. In these three scenario, we're going to we're going to use the data for testing. Okay, understand, right? The second points regarding the definition clear path and definition use path. A DEC path, definition clear DU path, represents a small function that can be tested by itself. So coming to the definition clear path, okay. Coming to the DC path, what is actually definition clear path? The definition clear path, we have only 2 points. One, in the path from where it actually starts from the definition. For example, if I take a variable name, so for example logs, so I need to define where actually the logs has been defined. So that is one point, and from that point to another point where this actually used, right? So from defined point to used point, there is only two things is there. One is definition, one is used. Okay, there is no other definition will comes in between that one. That is called definition clear path. Only one definition, only one used point. Okay, so this kind of paths can be considered as a function, a small function that can be tested by itself. Okay, that can be actually tested by itself. That is regarding the DC path. Coming to the DU path, if a DU path is not definition clear, I mean definition used path where it actually has many definition in between definition defined point as well as user point, there is many definition if actually there are many definition is there, then it should be tested for each defining node. Okay, so we need to test for each defining node, but in DC path only it can be tested by itself, but in DU path, for each definition path, for each defining node, we need to test for each defining node. That is the point we need to remember, right? Regarding the strategy of data flow testing. Okay, so this is regarding what data flow testing strategy. Okay, so the data flow testing strategies, data flow testing points are actually over. So let's move to the next concept called slice based testing. Okay, what exactly the slice based testing is? The definition is there. Okay, before writing, before going to read the definition, what exactly this slice based testing? I just explain with one clear example here. So slice, right? What is actually slice? Slice is nothing but a small portions, right? If a program is there, consider a a big program is there, right? So I'm going to make that big program into different slices. Slices mean different parts. So if you want to execute the test cases for the long program, it may time consuming, right? It may take more time for executing the test cases. But if you divide, if you make partition of that long program into different slices, different partition, then individually you need to execute test cases for these slices. Once you covered the major slices, then it is actually enough to execute the test cases. Instead of executing the test cases for the whole program, make the large program into small partition and execute the test cases for each partition or each slices. That is more than enough. You'll actually cover you if you execute the test cases for these slices, you are actually executing the test cases for the large program. That is a major idea here. Program is there, you divide the program into small slices and execute the test cases for simplification purpose. Okay, this is the main idea. Let us look for the definition. Of course, a program is there P and program graph G of P and set of variable. Okay, V is nothing but a set of variable. So nodes in the graph are actually the statement fragment. Node is nothing but just give the number to the different statement in your program. Just number the statement. That numbers is served as a nodes. Okay. So definition. What exactly the definition of a slice-based testing? The slice on the variable set V. So always remember when we are talking about the slices, we are talking about the variables. Uh, because the main thing in the program is variables only. In data flow testing also, we consider where exactly the variable is defined, where exactly the variable is used. In slice-based testing also, our focus is on variables only. Okay, we are going to make different partition of variable, different slices of variables. Okay, so this the slice on the variable set V at statement fragment n is actually written as S of Vn. Here V is nothing but the variable name, n is nothing but the line number where it is actually used or defined. Okay, this is the point. This is the representation we are going to use throughout our slice-based application. Slice-based testing. Yes, in bracket use variable name and n is nothing but the node number. Okay, so this sv comma n is the set of node numbers of all statement fragments in p prior to n that contribute to the values of variable in v at statement fragment n. Okay, this is actually the definition. So if you if I explain this with example, you will be clearly know this one. Let us go to the example. Okay, just check here. So in this one we have taken one program fragment here, program fragment from the commission problem from line number 13 to line number 20, right? So here if people just focus on this one, there are these slices and the logs. Okay, we are actually defining slices for a variable logs here, because in commission problem there are different variables will come like logs, stacks, barrels, total number of logs, local total stacks, total barrel, different variables will come. So for simplification, for understanding purpose, I have taken on a simple variable example for defining slicer for variable logs. That's why only few line numbers only I have taken from 13 to 20. Okay, so in this slide, if you take the first one, S1, so of course how to represent that is one yes, in bracket the variable name logs in the line number 13. Just check here. In 13 is logs. So only one variable is there, that is 13. Right? 13 is actually defined. That's why for S1 for the S1 the slice for logs is the line number 13. Right? If you consider 14 number line number S2, right? S2 also contains logs, right? S2 also contains log, right? S2 also contains logs. Here S2 is comma, I mean S logs comma 14, but here 13, 14, 19, 20 is there, right? Since this 14 is a while loop, it will start from 13, I mean the input, and it will follows 14, 15, I mean 14. 15 there is no lags, right? Only stacks barrels is there. 16, 16 we have a lags, right? Total lags is equal to total lags plus lags. 17 there is no lags here. That's why 17 is missing here. In 18 also there is no lags. Only 19 we have lags, right? Input lags. That way it will contain. 20 also we have end while loop, right? That's why from line number 14 to 20 it should contain. In the in between we have 14 and 19 where the lags actually used. That's why it will start from 13, 14, 19, 20. Again 16 also. For S3 lags, S of lags is equal to comma 16. It will start from 13, 14, 19, 20. If you consider the input lags, since it is only input, you only consider the 19. No need to write 13, 14, 19, 20 and all, right? This is actually how to write the slices for different variables. So here only one variable is there, that's why lags. Okay. Always remember when you starting the logs here, we are starting from 13, right? That's why only one number is the 13. In the end also, input logs only 13 and input logs 19. That's why only one line number is there, 13 and as well as 19. But considering 14, 16, you need to consider the whole loop 13, 14, 19, 20, 13, 14, 19, 20. Okay. So lattice of a slices. Lattice is nothing but consideration because a slice is a set of statement fragment numbers. We can find slices that are subsets of other slices. Of course, we can find the slices of subset of other slices also. This allows us to work backwards from points in a program, presumably where a fault is suspected. So when you execute in the test cases, our main focus is on this only. So if you able to find the backward point or backward tracing, then you can easily find a line number where actually the fault has been occurred. If you are able to find, if you are able to execute a backward trace, of course it's very important thing. If you able to conduct the backward traces for the slices, backward testing for the slices, you can easily identify where exactly the error occurred. If you identify the error, then it's very easy to remove the error and execute the test cases, right? There is another example here. The statement leading to the value of commission when it is output are an excellent example of this pattern, right? If you consider the commission problem, if you able to find the value of a commission, of course it, it is considered as excellent. Why? Because the statements leading to the value of commission, you only execute the value of a commission when all the programs fragments are, all the statements are true. I mean all the statements are error free. If this contains any errors, you can't execute the commission. That's why it's considered as an excellent example of the pattern. Okay. Some researchers propose that this is the way good programmers think when they debug code. Okay, that is another important thing here. Why it's very important here? When you are able to find the backward tracing of test cases, it is very useful to identify those error and remove the error and execute the test cases. The commission problem is one of the important and excellent example for this one, where if you are able to find the commission value correctly, then you can assume that there is no error in between the path, in between the slice. I mean, in the slice testing, right? Well, if there is any wrong number, I mean, a wrong in output of commission occurred, then you can backtrace that one. You can easily find the error. I can remove the error. Okay, this is the main importance of slices. So here, what are the different slices for S40 in the numbers here? S43 is there, 39, 41, 42 is there. Again, we need to move here. What exactly this is 14 down, right? Here 43, yes, right? Yes, 43 end commission here, right? Under this end commission, okay, what exactly this one? 40 under the 43. This is for commission, variable commission they are defining. So commission is actually used in where the number 31, 43, right? 43. So 43 is actually commission, right? 43 commission. Under that one we have the starting point 31, right? You can check here 39, 41, 42 is there. 43, 39, 41, 42. 43, 39. 39 where actually we use this is called backward tracing. So in the 43 where we actually use that one, in 39 we use that, right? 39 and 41 also. 41 also in the flow, and 42, 39, 41, 42. 39, 41, 42 if we use here, right? Commission. So if we again make that 39 into you know slices here, under 39 we have 38 is there, right? 39 else path 38 is there. There is no other path. So under 38 again 37 will come, right? 37 where we actually use that one, right? So 41 also 40, and 42 30. So finally all will comes at S30, right? What is actually S30? S30 is nothing but where we actually the starting point of commission problem, right? Then commission is equal to 0.10 into 1000. So in this way we are actually making commission problem. So in this way, this is actually the different way of commission problem. I mean different parts, the whole parts of complete lattice and commission. Under 30 also we have 31, 32, 23 to 34, 24, and 23, right? 23. So S30 is again divided into 3 slices. S23, 26, 29. 23, 26, 29. 23, 26, and 29, right? So in this way we define different variables for that. So this is actually your slice based testing. Okay, thank you.